Okay, properties of logarithms. These are the fundamental properties of logarithms. It says for any base b greater than 0, b can't be 1. Log base b of b is 1 since b to the 1 equals b. Log base b of 1 is 0 since b to the 0 is 1. And log base b of x is equal to x since b to the x equals b to the x. And log of b to the log base b of x is x. Now, by the way, depending upon what book you're using, these guys, two right here, are called the inverse properties. I don't think that's the way you spell inverse. Not even close. And if I take a look at this particular property, the outside function is the logarithm, that's the inverse. The inside function is the exponential, that's the regular function. So this particular process is f inverse of f of x. And if we remember what the inverse in a function does, it kills everything, and what you're left with is what you were started out with. This is also an inverse property. Here, the exponent is the log, and the base is the exponential. This is f of f inverse of x. That says every place I have an x, I put the inverse. Well, the inverse of the exponential is the log. And they're normally called the inverse properties. They're good for solving equations is what happens. We tend to use this guy a lot, number 3, without even thinking, but we don't use them as an inverse property. We normally use them as another property of logarithms, which you'll see. This guy I've used in calculus. It says, solve each equation by applying the fundamental properties. Answer in exact form. It's not exactly how you would necessarily choose to do this particular problem, by the way. And looking to see. When I look at this guy is log base 10. So I can rewrite him as x equals 10 to the negative 2.7. That's your exact answer. And if I use my calculator, it's approximately 0.002. Now, anytime I probably use my calculator is if I'm doing an application problem. I'd rewrite this guy, quite honestly. Natural log is log base e of x is equal to 1.6. That says e to the 1.6 is equal to x. This again is exact. And if I use my handy dandy calculator, it's approximately 4.953. We just wish everybody looked like that. That would be nice, but that's not the way the world works. It says solve each equation by applying the fundamental properties. All I did on this particular guy was to rewrite him as a logarithm because I can then get my hands on x. X is the exponent. And you're going to say, what did they really expect me to do to this problem? This ends up being a issue in calculus. Essentially, what they expected you to do was to take the natural log of both sides, since the log base e is natural log. You'd say the natural log of e to the x, this is the way we normally work with it anyway, is 7.289. Now, using the basic properties of logarithms, remember what natural log is. Natural log is log base e, and this is e to the x, is the natural log of 7.289. Fundamental property of logarithms says that log base e of e, these two things cancel each other out, and what you're left with is just x. So the exact answer is x is the natural log of 7.289, and the approximate on this guy, x is approximately 1.986. This is log base 10, so you use log base 10 on it. That's just log. So this is log of 10 to the x equals log of 0.001. This log is base 10. So using the fundamental properties, oh, that didn't work real well. These two guys take each other out. You're just left with x is log of, and this is log base 10, 0.001. So x is log of 0.001. That's your exact answer. And your approximate answer is -3. Now we're going to do things, I tend to do things a little differently than what this thing does, but once we get on tour,